To understand implicit differentiation, we need to understand what an implicit function is. So look at the slide, look at the screen in front of you. You can see that we have a circle graphed, and we've got an expression for that circle, which is this thing right here. Now, notice that the value of y depends on the value of x. Now tell me, is this a function? Is this a function? If you think back to earlier in the course, one way we could tell if this is a function is with the vertical line test. So if I pick any point on the x-axis and I walk up, notice that I cross the expression, I cross the curve more than once. So this is not a function. So it fails our vertical line test. This thing here is not a function. So we know this relationship is not a function, but what is it? Well, let's go through this slide. So it says we cannot write y as an explicit function of x. Now some of you might say, well, hold on a second, can't we do something like this? Well, I can't forget that I've got plus minus in front of that, and then so each x gives 2 y values. So it's not an explicit function. It's not going to give me one y value. It's going to give me sort of options for different y values. At the same time, our value of y does depend on x. And you can see that with this expression here. For example, if x is equal to 5, then y must be equal to what? Well, it's going to have to be equal to 0. Right? And if we go back, we can kind of see that if x is equal to 5, we'd be right there, and y is just equal to 0. So in that special case, it gives us one y value. So there is a relationship between y and x. And that relationship we are going to define as an implicit function. And so we say that y implicitly is a function of x. Now that we know that this is an implicit function, the rest of this topic is going to be focusing on the differential calculus using functions like this, using these implicit functions. So what we're going to do today is we're going to try and figure out what the slope of this circle is if x is equal to 4, for example. So we know from before that we're going to have some sort of tangent line. How can we find the slope of this tangent line right here? That's what we're going to do today. So how can we find the slope of that circle at a specific point? Well, we can use the chain rule and what we just saw, which is that y depends on x. Now we've got a recipe here for how to find the implicit differential. Take a look at our example up here. I'm going to give you a trick, but please just realize this is a trick for me to help you see what's going on. So we know that the value of y depends on x. So for illustration purposes, I'm going to rewrite this expression as follows. I'm going to write y as an explicit function of x, even though that's not entirely true, but I'm going to show it to you because I think it's really going to help you see what's going on with this problem. Now I'm going to take the derivative of this thing with respect to x. And so what am I going to get? I'm going to get 2yx times y prime x, right? I'm using the chain rule, plus 2x equals 0. So I've used the chain rule. I took the derivative of both sides of this expression, this implicit function. And now I'm going to follow the second step, which is to rearrange this thing and solve for the derivative, which is going to be y prime, or the way that I've written here, y prime x. So we don't need that there. I'm going to isolate and solve for this thing. So we're going to have 2y of x is equal to y prime x is equal to negative 2x, and y prime of x is equal to negative 2x over 2y of x, and that's going to be equal to negative x over y of x. Now, I told you that this is a trick, so I don't want you to write it in this manner, even on the test, and I certainly don't want you leaving the course and thinking this is how we normally find implicit differentials. So I'm going to move this over to the side, and what you'll see in the textbook is you won't see this part right here. That'll be gone. All you'll have is this expression right here, and I'm going to take the derivative of both sides. I'll make sure that I write it properly here. And we just assume that y depends on x. So again, we're going to apply the chain rule, and this time we're going to see 2y prime plus 2x equals 0. Derivative of the constants just equal to 0. And then we're going to solve for y prime, negative 2x, and then y prime is equal to negative 2x over 2y, which is just equal to negative x over y. And so that's what you're going to see in the textbook. This is the way you should do it on the test. But I wanted to rewrite it with this little function here because it builds on something you already know, and it really clearly illustrates how we're using the chain rule to find the implicit differential. Now, remember, we wanted to find the slope at a certain point on the circle. So let's take a look at the coordinates 3, negative 4, and let's see if we can use the implicit differential that we calculated to find the slope. So here is the graph, and we have 2x plus 2y y prime is equal to 0, and we ended up with y prime is equal to negative x over y. Now, if we want to find x equals 3, y equals negative 4, this is our point right here. And so we want to find the slope of this thing, this tangent line, and we get y prime is equal to negative 3 over negative 4, which is equal to 3 over 4. And you can see that the tangent line is upward sloping, and 3 over 4 looks pretty reasonable.